A sample space is the set of all possible outcomes of a random process or experiment. An event is a subset of a sample space. If S is a finite sample space in which all outcomes are equally likely and E is an event in S, then the probability of E is the number of outcomes in E over the total number of outcomes in S. So let us put pieces together. Please take a look at the following example. Let us roll 2 dice. Question number 1, use the compact notation to write the sample space S of possible outcomes. So let me put 2 slides together over here. So let us read once again what is a sample space. A sample space is the set of all possible outcomes of a random process or experiment. So here we want to write down the sample space of all possible outcomes. We roll 2 dice. Therefore, all possible outcomes are 1 on die number 1 and 1 on die number 2. 1 on die number 1, 2 on die number 2. 1 on die number 1, 3 on die number 2, and so on. So what we see in front of us is the sample space. Number 2, use the set notation to write down the event E that the numbers showing face up have a sum of 6. Here it is. Here is this event. Die number 1, 1. Die number 2, 5. Die number 1, 2. Die number 2, 4. And so on. Note that this event is indeed a subset of the sample space. Lastly, in order to find the probability of this event, we divide the number of elements here, which is 5, by the number of elements here, which is 36. Guys, any questions here?
So an event is like a function where the output of the function is all the outcomes that satisfy the event?
No. An event is not a function. An event is a subset of a sample space. So please take a look. First of all, let us go back to the definition. An event is a subset of a sample space. Sample space is this. An event is this. Note that E is a subset of S. An event is a subset. What do you think?
This makes sense.
Now, probability of this event is the number of elements here over the number of elements here, which is exactly what is written here. Okay, let us discuss other examples. Please take a look at this. We toss 3 coins, all right? The sample space of possible outcomes. Guys, anybody who can help me with that?
Head.
So, since we toss 3 coins, the sample space of possible outcomes will be head. Do you agree with us?
No.
No. So, what do you think?
There should be 8 possible outcomes.
I mean, yeah,
I think.
there are more.
8 possible outcomes. Why 8 possible outcomes?
It's 2 cubes.
Can you list all elements of this sample space?
Might take a while.
Yes,
like,
but try.
Those like heads, yeah, heads, tails, heads, tail, tail. Tail. They can do it. the other way where it's like tail, tail, head, head. And then you also have head, tail, head, and tail, head, tail.
Absolutely. So we have three positions. Position number one is for coin number one, position number two for coin number two, position number three for coin number three. How many combinations do we have? 8. H, 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 T, H, T, H, and so on. Guys, you all agree with me? Next, what is the probability that 0 heads are obtained? Anybody?
Is it 1/8?
1/8. Why is that?
Because of all the outcomes, only one has no heads, and that's tails, tails, tails.
Exactly. So this event consists of just one element, T, T, T. So the top of our fraction is 1. The bottom of our fraction is the number of elements in the sample space, which is 8, 1/8. Perfect. Anybody else? What is the probability that one head is obtained?
3/8.
3/8.
3/8. Absolutely. The event consists of 3 elements. T, H, 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 T, H, and H, H, T. So top is 3, bottom as before, 8, 3/8. What is the probability that 2 heads are obtained? Anybody?
3/8 again.
Again, 3/8. Because 2 heads means H, H, T, H, T, H, and T, H, H. Lastly, what is the probability that 3 heads are obtained?
1/8.
1/8. Why is that?
Because H, it's only
Because this event consists of just one element, H, H, H. Number 2, we toss a die. Write the sample space of possible outcomes. Anybody? What is the sample space of possible outcomes?
1, 2, 3, 4, 5, 6.
Exactly. 1, 2, 3, 4, 5, 6. What is the probability that the number showing face up is 1?
1/6.
1 divided by 6, because this event consists of just one element, 1. Correct? In C, what is the probability that the number showing face up is even?
2/6. 3/6.
Which is?
1/2.
Yes. The probability of this event is 1/2, because this event consists of 3 elements, 2, 4, and 6. So it's 3/6, which is 1/2. D, what is the probability that the number showing face up is prime?
3/8.
Again, 3/6, which is 1/2, because we have only 3 prime numbers between 1 and 6. It's 2, 3, and 5. Okay, lastly, number 3. We toss 2 dice. How many possible outcomes are there? We already discussed 36. It's this example, correct? Over here, 36. What is the probability that the numbers showing face up are equal? Can anybody tell me?
I think 6/36.
6/36, because this event consists of 6 elements, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So it's 6/36, which is the same as 1/6. What is the probability that the numbers showing face up have a sum of 6? We already discussed. It's 5/36. Lastly, what is the probability that the numbers showing face up are different?
30 over 36, 5 over 6,
Why do you think that this is 5 over 6?
because equal are 1 by 6. So 1 minus 5, 1 by 6 is 5 by 6.
Okay, so let us count the number of elements in this event. Numbers are different. The total number of elements in the sample space is 36. Now, going back to B, when numbers are equal, this event consists of 6 elements. Therefore, when numbers are different, this event consists of 30 elements. Conclusion: this probability is equal to 30 divided by 36, and cancel out 6, we get 5 over 6.